Hello everyone, how's it going? I hope you are doing well. Welcome to this video. This is a video part number 2 from the test-driven development episode, and if you didn't watch the video part number 1, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? Sorry, nothing. What's wrong? Okay, remember the last session you implemented a very super easy module, that add module, and you gave it to your boss. Today your stand boss comes to you and tells you that dumb like module you have written doesn't work when we give it a double as first parameter and an integer as second parameter. It doesn't compile. Okay, what would you say? You say not at all, because you have written 2 test cases and you're sure it works. Okay, enough. Let me tell you something. Test-driven development is a very useful tool, but it's not a silver bullet. You should make sure to implement sufficient test cases for every subject under test. Alright, let's fix the bug. Before that, don't forget to check out the branch for this session. This is the video part number 2, and it means you should check out the branch session 2. Okay, let's do it. Open up the Visual Studio Code, and on a status bar, click on branch button and then click on session 2. Okay, how would you want to fix this bug? Let me tell you. You would probably open up your module source code and then looking at, and suddenly, okay, I got it. The bug is here. I should define another template parameter and then stop. Just a stop. What's wrong with you? You're completely wrong. In test-driven development, don't touch any code without any test case that you are sure it was failed. Okay, what should we do? At first, undo everything that you have done. Alright. Then, you should write a test case that shows you that bug. Okay, let's implement another test case. Test fixture. Add function should add up to real, should add up an integer with a real number. Same as previous test case, I can copy that, 2.2 and 4. Sorry. Alright, now run the test cases, rebuild all project. Okay, it's failed, as your boss said. Now we can fix the bug. Define new template parameter and run the test case again. Okay, you are done. Now it's time to clean up the design. I think it's very clean. There's nothing to clean up. Okay. Think a little more at this line. Don't you think return type has a problem? Yes, it has. If we give an integer as first parameter and a real number as second parameter, the return type would be an integer, and it's wrong. Okay, let's write a test to show the problem. Test f and test fixture, add function should add up a real number with an integer. Same as previous test. We can copy that. Now run the test case. Okay, it's failed. Now we can fix the problem. What's your suggestion? I'm going to fix it through one of the amazing features in C++14. You can replace the return type of function with the auto keyword, and you should write something here. Dec type A plus B. Okay, what is this? Actually, this expression specifies the return type. What is this function? I mean dec type. Dec type is a function that takes an expression and returns its type at completion type. At this point, it returns the type of this expression that we need. Okay, let me tell you another thing. In C++17, you can also remove this part. Okay, we can run the test cases again. Okay, it's passed. You're done. Now you can give it to your boss. But suppose your boss right now comes to your office and says, could you add a new feature while you're fixing it? Okay, what's the feature? The add function should support new argument type, and it is a standard vector. Okay, it's not that much hard. Interesting. Let's implement the feature. But before that, remember the test-driven development cycle again. Write a test, get it to pass, and clean the design. Okay, let's add the new test case. Back to the code and implement a new test case. Test f macro, test fixture. Okay, and test case name, add function should add up a vector of real numbers. Okay, create a vector. And same as the previous test case, pass the vector to the add function and validate the result. Okay, now we can run the test case to ensure it's failed. It doesn't compile because the add function doesn't support a vector as its argument. The next step, let's pass the test. We should override a new function to support standard vector as its argument. Std vector. To add up all of the vector values, I'm going to use the accumulate function in the standard numeric library. This function takes 3 parameters. The first one is the beginning of the container. The second one is the end. And the third parameter is the initial value. Don't forget to include the numeric library and vector. Okay, to know more about the accumulate function, you can read its documentation in CPP reference website. Now we can run the test cases. Okay, you're done. All of the test cases are passed. The next step, clean up the design. Okay, I think all are clean. There's nothing to clean up. Look at this line. Don't you think it should also support other container types like standard array or something like this? Yes, it should. Let's implement it. First, write a test case and feed the new container type to add function. Test f macro, test fixture, add function should add up an array of real numbers. Standard array type takes two template parameters. The first one is the type and the second one is the size of the array. Same as the previous test case, and fit the new type. I'm in a standard array. Okay, run test cases to ensure it's failed. Okay, it's failed because the add function doesn't support the standard array type. We can use templates to implement it in a more generic way. Template, type name, container type. Alright, we can also turn the return type to auto. Run the test cases to ensure it's passed. You're done. All of the test cases are passed. The next step, clean up the design. I think all are clean. There's nothing to clean up right now. Okay, I'm going to ask you a question. Do you think this function supports all of the typical standard containers? I don't think so. Do you think it supports the standard initializer list? Okay, let's test it. I'm gonna add a new test case. Test f macro, test fixture, add function should add up initializer list. Auto list. Same as previous test case. Validate the result. Okay, what is it? When you use a braced initializer, the compiler deduces the type of variable as a standard initializer. This is one of the C++ 11 standard features. Last session, I played part of a video from Scott Meyers. It was about type deduction in C++. I put a link of this video in the comment section. I really recommend you to watch this video completely because I think the first step to come into the C++ modern world is to know about type deduction in C++ modern. Let's run test cases to ensure it's failed. Oh my goodness, it's passed. I was wrong. Okay, you're done. Now you can give the module to your boss. If you have noticed, we have used automatic type deduction a lot through auto keyword, but you should be careful about it. If you use the auto keyword as much as you can, maybe it causes some problems. I'm going to play a short video from CPPCon 2018 about it.
God afton, mina vänner. Bonsoir, mes amis. Guten Abend, meine Freunden. Good evening, friends. I stand before you tonight to talk about a scourge that has infected code bases east and west. I refer, of course, to the dramatic overviews of the auto keyword in our code bases. So that's just for the camera. The question then becomes, why auto? And I think to answer this, we have to look at the composition of our hardworking and underpaid volunteer committee members. They were faced in the early days with a large dilemma. Many of them would spend inordinate amounts of time traveling around the globe, making presentations, trying to keep the spirit of C++ alive. And this, in my mind, leads me to one of probably the main reason why auto exists in the language. It enables slideware. One can look at the difficulties involved for the poor person having to write a pre-C++ 11 slide. And I recognize this is C++ 17, but trying to fit anything on a slide pre-11 was difficult. And one can understand that there is a certain allure when presented with the modern alternative. Now, of course, to be fair, there are very great uses for the auto keywords, and there are indeed some things that you just cannot do without it. Beautiful things like naming lambdas and then renaming them. Impossible before. The problem is the dramatic overuse. Now, at this point, we can look at a few ways that the overuse has shown up. So, at this point, we have to look back at a humble, underpaid software engineer sitting in a hotel room at 2 o'clock in the morning. The phone rings, and it's the production group. The system has crashed, and they're refusing to start it unless we can guarantee that the crash won't happen again. So you do what you have to do and basically bring up the autodial modem and dial in and set up a DDB session. And we find that somebody has very nicely produced a totally excessive return value chain. So we go in and we take a look at the first line of the call and go, well, okay, this seems a normal line. It's not too bad, but let's see where it leads. There's something wrong with retval, is about all we know so far. But, oh well, yeah, what a surprise. That comes from somewhere else. Now we're digging 20 files further down the directory tree. And, oh, that one doesn't do it either. Well, oh, okay. That returns a UN64. Hang on, what was the question again? In which file? Had that been an int, it wouldn't even have been shorter than auto as a keyword. Then again, there's the whole qualifier confusion in auto. So we have a few pointers. We could declare them visibly as pointers. And it doesn't actually matter how we declare them because they're all the same deduced type. Then, of course, there's people that believe that auto actually means what's on the right-hand side. Well, maybe not. Because auto is template deduction, as I understand it. Of course, template deduction will tear off the top-level const volatile qualifiers. So you can assign to an auto from a const. And if you try to spin on a volatile, you're probably going to be spinning for quite some time.
Okay, we are done. We're coming to the end of this video. Remember that you learn best when you get your hands dirty and follow along with the examples. I hope you enjoyed it. Thank you so much and have a nice one.